You're at a red light, wondering whether you're destroying your transmission. A full automatic replacement averages $5,892 to $6,402, according to RepairPal's 2025 data. That's why the worry won't shut up. 3 driving habits get argued about online: holding the brake in drive, shifting to park at long lights, and creeping in traffic. One is a myth, one is dangerous, and one matters but not for the reason you've been told. Automatic transmissions have their own logic, and it starts with the torque converter. Unlike a manual, where the driver disconnects the engine from the wheels with a clutch, a torque converter uses fluid to do the job. This is the reason an automatic can sit and drive at a red light, brake applied, without lurching or stalling. The engine spins the impeller inside the converter, which throws transmission fluid against a turbine connected to the transmission input shaft. The fluid coupling means there is no direct metal-on-metal connection, just a controlled slip, cushioned by oil. Bob Warnke, an engineer at Sonnax, explains it this way. The torque converter is designed to let the engine turn while the car stands still. Holding the brake in drive is normal, and the transmission expects it. That is why, when you are stopped in traffic, the car inches forward as soon as you lift your foot. This low-speed creep is not a flaw. It is exactly what the system was built to do. The converter stator multiplies torque at low speed, giving you that gentle push without straining the clutches. Some drivers worry that sitting in drive at a stoplight is burning up the transmission, but the numbers tell a different story. At idle, the converter generates about 400 to 800 watts of heat, depending on engine size and vehicle weight. In practical terms, that is a modest temperature rise, nowhere near the threshold where automatic transmission fluid starts to break down. Engineering tests show that a typical red light stop, even with the brake held and the engine idling, does not push automatic transmission fluid temperatures into the danger zone. The real heat comes from towing, high-speed driving, or a failing cooling system, not from ordinary city traffic. There is a reason advice from manual transmission forums does not map cleanly to automatics. In a manual, holding the clutch at a stop wears out the friction disc. In a torque converter automatic, the fluid takes the load, and the internal clutches stay fully engaged. That is why creeping in drive or waiting at a light with your foot on the brake is not only safe, it is the default design. The only real risk comes from ignoring the difference between transmission types. Dual clutch automatics, for example, do use friction clutches that can wear from creeping. But for the vast majority of torque converter automatics, the system is built to handle stop-and-go traffic all day long. The fear that you are killing your transmission by sitting in drive at a red light just does not hold up to engineering reality. Automaker owners' manuals, Ford, Toyota, Honda, GM, Subaru, do not urge drivers to shift into neutral at red lights. There is no warning about transmission wear, no advice to make neutral a habit at every stop. Manuals do caution against shifting between drive and neutral while moving, since snapping back into drive can stress internal clutches. But when the car is fully stopped, the silence is telling. The absence of guidance is not oversight. It reflects the reality that, for most drivers, this choice barely registers as a maintenance concern. General Motors took the question seriously enough to patent neutral idle control, U.S. Patent 6,123,645. Instead of relying on drivers, the car's computer can temporarily slip the forward clutch when stopped, reducing torque converter drag and cutting idle heat. The patent's language is clear. This is a minor efficiency tweak, not a safeguard against disaster. Mazda, Audi, and Honda have introduced similar automated systems, all aimed at squeezing out marginal gains in fuel economy, not preventing catastrophic failure. Peer-reviewed research in control engineering practice modeled torque converter slip loss at stops. The findings are clear. The converter generates its highest heat at stall with the brake applied, but the temperature bump during a typical red light is modest. Fluid temperatures rise by a few degrees, never approaching danger unless idling for many minutes or towing heavy loads. The numbers, hundreds of watts of heat, not thousands, reinforce the idea that this is a small optimization, not a looming threat. Transmission shops sometimes warn about excessive shifting between drive and neutral, but the concern is mechanical wear on the shift lever and linkage over thousands of cycles, not heat. As engineer Jason Fenske notes, torque converter automatics are built to idle in drive. The real risks, overheating, fluid breakdown, expensive repairs, come from neglecting maintenance, not from leaving the shifter alone at a stoplight. Shifting to neutral at every red light is a marginal debate, not a decisive one. The heat is real, but the impact is minor. Every automatic driver has wondered, is shifting to park at a red light a clever move or a hidden trap? The answer starts with a part most people never see, the parking pal. Inside the transmission, this steel pin locks into a notched gear when you select park. Its job is simple. Keep the car from rolling when you're stopped and turned off, but it is not built to absorb force from a moving car. That is where the real risk comes in. At a red light, putting the shifter in park does not protect your transmission from wear. Instead, it exposes the parking pal to a different kind of danger, rear-end collisions. If someone hits your car from behind while you are in park, all the impact energy travels straight into that tiny locking pin. Jason Fenske, an engineer known for breaking down automotive myths, warns that a strong enough hit can shear the pal clean off. Once that happens, the car can roll away, and the transmission may be filled with metal debris. This is not just theory. In 2015, a Honda Accord coupe owner described on Just Answer how a rear-end crash at a stoplight caused the pal to fail. The car, now unlocked, rolled 30 to 50 feet before coming to rest. Internal damage followed, leading to a costly repair, far more than any supposed benefit from shifting to park at a light. Automaker manuals and engineering sources agree, park is for when you are fully stopped and secure, not for traffic signals. The real threat is not from shifting wear, but from the sudden force of a collision. For everyday drivers, that means the safest place for your shifter at a red light is anywhere but park. Manuals do not leave much room for debate on a few key points. The first is simple: never shift from neutral to drive while your car is still rolling. The 2020 Hyundai Kona manual spells it out clearly. Moving the lever back to drive before a complete stop can severely damage the transmission. That is not just a suggestion, it is a mechanical reality. When the car is moving, the clutches and bands inside the transmission are already engaged for one gear. Forcing a sudden change while the wheels are turning puts shock loads on those parts. Over time, that kind of stress can shear friction material, warp clutch packs, or even snap internal components. No automaker wants to pay for that repair under warranty, and no driver wants to foot a bill that can run into the thousands. The second rule is about parking. When you stop for good, at home, at work, anywhere the car will sit, always apply the parking brake before shifting into park. Subaru's Forester manual explains why. The parking brake takes the weight of the vehicle, so the transmission's parking pal is not forced to hold the load. If you put the car in park first, especially on a hill, the entire mass of the car locks against a small steel pin inside the transmission. That pin, called the parking pal, is designed to keep a stationary car from rolling, not to absorb the force of a car settling or shifting on an incline. Relying on the pal alone can jam the shifter, make it hard to get out of park, or in the worst cases, break the mechanism entirely. That is a repair no one wants. These are not style points or personal preferences. They are hard rules, grounded in engineering and spelled out in black and white by the people who built the car. So while debates about shifting to neutral at stoplights might come down to habit, these two actions, never shifting into drive while moving and always using the parking brake before park, are non-negotiable if you want your transmission to last. Heat is the silent killer inside every automatic transmission. The numbers from the Automatic Transmission Rebuilders Association are blunt. 9 out of 10 transmission failures can be traced directly to overheating. This isn't about what gear you use at a red light. It is about what happens when temperatures start to climb past what the fluid can handle. Transmission fluid is not just a lubricant, it is the lifeblood that cools, cleans, and protects every moving part. but it has a breaking point. According to TCI Auto, once the fluid hits 240 degrees Fahrenheit, the additives that prevent wear and oxidation begin to break down. At 260 degrees Fahrenheit, the rubber seals inside the transmission start to harden. That is when leaks develop, shifts get rough, and the countdown to failure begins. Bennett Fitch, a reliability expert at Noria Corporation, points to the Arrhenius rate rule, a simple law of chemistry that hits drivers in the wallet. For every 18 degrees Fahrenheit rise in fluid temperature, the life of the fluid is cut in half. If your transmission runs at 200 degrees Fahrenheit, the fluid might last 100,000 miles. Bump that up to 218 degrees Fahrenheit, and you are down to 50,000 miles. Push it to 236 degrees Fahrenheit, and you are looking at just 25,000 miles before the fluid is spent. The spiral is unforgiving. As the fluid breaks down, it loses its ability to carry heat away, which means the transmission runs even hotter and the damage accelerates. This is why engineers and service pros keep coming back to heat, not stoplight habits, as the real threat. The transmission was built to idle and drive, but it was never meant to survive on burnt fluid. Ignore the temperature, and even the most careful shifting will not save you from a $5,000 repair bill. Transmission failures often make headlines, but the real story is not always about what drivers do at red lights. Take the Toyota and Lexus UA80 8-speed automatic. In 2024, a class action lawsuit landed squarely on Toyota's doorstep, not because owners were shifting wrong at stoplights, but because the software running the transmission was flawed from the factory. The complaint pointed to overheating and abrupt shifting, all traced back to calibration logic in the transmission control module. Toyota's own technical bulletins called for a software update, not a lecture on driving habits. The fix came as a reflash at the dealer, not a change in what drivers did with their shifter. That is not an isolated story. Nissan's CVT settlement, covering over 500,000 vehicles, with a July 2025 hearing on the docket, centers on cooling system design and internal beltware, issues that cannot be solved by babying the shifter at red lights. Ford's 6F35 Automatic, another name that comes up in lawsuits, faced complaints about harsh shifting and early failure, with root causes tied to hydraulic design and solenoid reliability. The DPS-6, Ford's dual clutch unit, racked up its own pile of legal filings over shuddering and slipping, again problems baked into the platform, not created by the person behind the wheel. ZF's 9-speed automatic, used in vehicles from Jeep to Honda, rounds out the list. Owners reported rough shifts and transmission failures, with investigations pointing to software calibration and manufacturing tolerances. Each of these examples highlights a simple truth. Transmission failures often reflect choices made in the engineering department, not mistakes at red lights. Conventional automatics, CVT transmissions, and dual clutch transmissions do not fail for the same reasons. What breaks a Nissan CVT will not hurt a Toyota UA80, and advice for a dual clutch does not apply to a torque converter automatic. The pattern is clear. Platform-specific flaws, not driver error, drive most of the big-ticket failures making news. The real risk to your wallet is not how you shift at a stop, it is whether your transmission was built and programmed to handle the job. The label lifetime fluid appears in owners' manuals and service schedules across the industry, but its meaning is less straightforward than it sounds. For many drivers, the promise feels absolute. Top up the fluid at the factory and the transmission will outlast the car. Automaker language, though, tells a different story, one that is more about warranty math than mechanical immortality. BMW was among the first to use the phrase, backing it up with a specific number, 100,000 miles. In their own testing documents, lifetime means the duration of the factory warranty, not the total lifespan of the vehicle. Gareth Foley at FCP Euro, who specializes in European transmission service, points out that the acceptable rate of failure in this context is not zero. Manufacturers expect a small percentage of transmissions to fail just outside the warranty window, and that is baked into the business model. The real question is whether the fluid will protect the transmission for 200,000 miles, not just the first 100,000. ZF, the German supplier behind the 8HP automatic found in BMW, Jeep, and other brands, quietly contradicts the lifetime claim in their own service bulletins. ZF recommends fluid changes every 50,000 to 62,000 miles, or 80,000 to 100,000 kilometers, regardless of what the automaker prints in the glove box manual. This is not a small difference. It is a direct challenge from the company that actually engineered the gearbox. Gareth Foley puts it bluntly. Lifetime is just a marketing term. If you want your transmission to last as long as the car, you have to change the fluid. The car care nut, a former Toyota technician known for deep dives into factory service data, says even Toyota's world standard fluid, often labeled as lifetime, struggles to go beyond 100,000 miles without forming varnish deposits and shifting roughness. He recommends a 60,000-mile interval for most drivers, well before any warning lights or symptoms appear. The pattern is clear. Lifetime fluid is designed to get most cars through the warranty period with minimal maintenance, lowering the automaker's cost per vehicle. But for owners who plan to keep their car past the first decade, relying on the factory fill is a gamble. The experts, the supplier, and the service pros all agree the safest bet is to treat fluid as a service item, not a permanent fixture. A single number cuts through all the debate: $5,892 to $6,402. That is what the average driver faces for a full automatic transmission replacement in 2025, according to RepairPal and J.D. Power. Even mainstream models routinely top $4,000. Luxury owners can see bills well north of $6,000. Against that, the cost of a routine drain and fill, $80 to $250 at a shop, or half that for do-it-yourself, barely registers. Yet thousands of transmissions die every year, not from driver error at red lights, but from fluid that is simply worn out. This is where the 60,000-mile mark becomes more than a service interval. It is a dividing line between cars that keep going and cars that end up on a flatbed. Transmission fluid is not immortal, no matter what the marketing says. The additive package inside every bottle, detergents, anti-wear agents, seal conditioners, starts to break down long before most drivers think. TCI Auto and Noria's Bennett Fitch both point to the chemistry. For every 18 degrees Fahrenheit above normal, fluid life gets cut in half. That means even moderate heat, compounded over years and miles, slowly erases the protection your transmission depends on. Automakers might label their fluid as lifetime, but that word usually means until the warranty runs out. BMW's own test documents set lifetime at 100,000 miles. ZF, the company behind some of the world's most popular automatics, quietly recommends changing fluid every 50,000 to 62,000 miles, regardless of what the owner's manual says. Gareth Foley at FCP Euro and Toyota trained techs like the car care nut both land on the same advice. Treat 60,000 miles as your real deadline, wait longer, and you are gambling with a component that is second only to the engine in replacement cost. Plenty of transmissions reach 150,000 or even 200,000 miles with nothing more than regular fluid changes, but neglect is the silent killer. Most failures, according to the Automatic Transmission Rebuilders Association, trace straight back to burnt or degraded fluid, not to how the shifter was used at a stoplight. The message is blunt. Stop worrying about every red light habit and start focusing on the one thing you can control. Change your fluid at 60,000-mile intervals, and you turn a multi-thousand-dollar risk into a basic maintenance chore. The difference is not subtle. It is the difference between a car that lasts and one that leaves you stranded. Right now, most automatic failures still trace back to heat and neglected fluid, not red light rituals. Original equipment manufacturer manuals and engineers agree. Keeping your torque converter automatic in drive at a stop is safe, but skipping fluid service is not. In 2024, lifetime fluid claims remain marketing, not mechanics. Protect your wallet. Trust expert guidance over internet myths. Your transmission's real enemy is silence, not shifting. Drop your questions and stories below.